In this video, we are going to learn about different types of pollutants you might expect in stormwater at different locations. So the common pollutants that we normally find in stormwaters are sediments, which is expressed as total suspended solid or TSS, temperatures, pH, salt or salinity or total dissolved salts. So that's called TDS. And then oxygen demanding pollutants like BOD, COD, which includes oil and grease or other organics. Other pollutants include nutrients, which could be different types of pollutants. Either it's a nitrogen or phosphorus. Nitrogen including nitrates, ammonia, phosphorus including particulate phosphate and orthophosphate or PO4. And then heavy metals. Heavy metals include lead, zinc, copper, cadmiums. These are the most common heavy metals you find in stormwater. And then specific organic pollutants like polyaromatic hydrocarbon, PFAS, micropollutant like PFAS. This could be origin from, many of them are origin from different source. It could be pesticide, herbicide, all that. And the last one is pathogens. Pathogens including different types of bacteria like fecal indicator bacteria, E. coli, coliforms. So if you go to different BMP database, which I encourage you to take, and there you can find concentrations of different pollutants reported throughout US and any other countries. This is a very good database where you can also estimate the effect of different BMP on the removal of those pollutants. So this is again, you go to BMP statistical tools. There, if you pick up the pollutants, you will be able to identify them as well. So if you see the units of different pollutants, they are different. So we are going to learn today about those units and how that units varies for different pollutant types and when to use it, and then how to get all the different numbers. Now here is the average concentration of different pollutants. You can see nitrogen, total candle nitrogen, organic nitrogen, nitrate, nitrogen dioxides, total phosphate, dissolved phosphate, orthophosphate. I encourage you to check all of them. This is in the book, and so this is based on the BMP database. Again, go back to the BMP database and check these numbers if you wanted to change. And what I want you to look at is that each of these different pollutants are expressed a different way. For instance, for nutrients, it says milligram per liter as nitrogen and milligram per liter as phosphate. That means, when you have different types of species which contributes to nutrients or nitrogen, it's important to express them as the same unit so that you can add them up or subtract them up. So that's why they are expressed as a single form. Your coliform is colonies per 100 ml water, and sometimes you say these heavy metals are expressed as microgram per liters. And so that means you will be able to identify that there are many different types of units, and we are going to learn about those products, why to use it. And these concentrations of pollutants has different effects, and it particularly impair different stormwater for different use. For instance, here you can see, just by looking at these pictures, you can see this water looks very murky or very turbid or has a lot of particulates. So that's what is the cause of the pollutions here. It's a total suspended solid. So this looks brown. And then you can see that in some cases, the fish are dying. And so this is a symptom of low dissolved oxygens. And then you can see that, sometimes you can see the color turns to green, which is basically reason behind is algae. And algae blooms because of high nutrient concentrations like nitrogen and phosphorus. And then sometimes you may see the stormwater is very clean. Doesn't mean that it's clean, because there would be dissolved pollutants that might have in high concentrations. So that's why it's very important to measure the concentration of different pollutants so that we can predict, or at least we can learn when they are impaired or not. And see, this impairment can last long time. And so the depends on different pollutants, the impairment will last different times. So what we wanted to see here is that what are the different pollutants and how long it expect to last. First is hydraulic effect. Hydraulic effect is related to water, how quickly water moves, that's related to pondings and all that. So as you can see, this most of the time it rains. As soon as the rain is over, the water flow rate will change, or you can see that most in well-drained system there will be less of water remaining. So that means the hydraulic effect will last for hours, which is typically within 1 hour of rainfall. After the rainfall, most of the things to clear out. Then oxygen. Oxygen can be depleted because of immediate loading of many biochemical oxygen demands, or BOD, and that would last for at least a day, because within that days, most of the organics will be consumed by bacteria. So you'll expect the oxygen concentration to go back up. Whereas suspended solid, you can see here, suspended solid is basically lasts for about like a 1 day to sometimes a month or a year. And that's because this suspended solid could be remain in the system and remain in the sediments and continue to have the effect or negative effects. And then you can see the toxic pollutants such as heavy metals that last for sometimes short time, or organic pollutant that could last for long time based on how long it takes for degradation to occur. And here you can see bacterial pollutant that's basically lasts for a day or few days. Within a week, most of the bacterial pollution decreases because of just the dying of bacteria by natural bacteria colonies, or because of sunlight. So at the same time, if you look at the nutrients like nitrogen or hydrogen sulfide, they are very short last because they are gas. Gas can be released from the water, so that's why they will last for maximum hour or few hours maximum. However, if you think of nutrients, the nutrients can last for from weeks to 10 years. That's because of algae and other content. So that's why it's important to think of these lasting, how long they last, so that you can understand how long this effect will be visible. And then also this pollution effect could be also dependent on the scale. Some of the pollutants is a large scale. For instance, you can see algae bloom. It takes weeks to see that, but it can last for many years. But this can also affect in the large scale systems like big lakes. Whereas sedimentations would be mostly localized. You will not experience that in the larger scale system. Mostly those sediments will be sediments will be observed in the inlets of the stormwater locations in a pond or an inlet of the big lakes. And the other end of the lake, you will not see the sedimentations because of the sediment or TSS because of sedimentations. So you can see all these different effects, and this will help you determine the effect of different pollutants in a different stormwater system or surface water systems. And with that, let's see how well we learned which pollutants would affect public health within a day. Your option is pathogens, nutrients, metals, and petroleum. I'd like you to pause the video here and give a thought based on what you learned. So I'll take a 10-second pause so that you have time to pause it and think. All right, so the answer here is pathogens. As you see from these previous slides, most of the within a day, the effect is usually bacterial pollutions. It's basically 1 day, and because that's basically bacteria die within a day, or because of sunlight, other things, they will decay eventually. Whereas nutrients takes long time, metals will not degrade, and petroleum compounds also takes long time to because organic. All right, so that's the end of this lectures or the end of this video.